Hey guys, this is Pratik and you're watching Technocrat. When you're recording sound or when you're recording video or when you want to download an audio track from the internet, you're given an option to choose between various bit rates. So how does this make a difference? How does this enhance the quality of audio? We see that few audio files always insist on choosing the higher quality bitrate. But then how does this affect the quality of audio that we get? Basically, as the name suggests, bitrate is the number of bits that are used to represent 1 second of audio data. So there are two factors that would contribute to the bitrate, that is the sampling rate as well as the bit depth. You need to have a basic understanding of how an audio signal is sampled and discretized into a digital signal. The audio signal is converted from analog to digital using a scheme called pulse code modulation. In this scheme, the time axis as well as the amplitude axis both are discretized. So how frequently should you pick the time samples is given by the sampling rate, and with how many number of discrete values should you sample the amplitude axis is given by the bit depth. So let's look at the sampling rate at first. As Fourier proposes, any wave, so even the sound wave, has infinite number of frequency components present in it. The audible frequency of human range is 20 to 20 kHz, as you might know. So ideally, say suppose you are listening to a sinusoidal sound signal which has a frequency of 20 kHz, which you ideally won't be able to hear. So if you want to convert this sound to a digital audio, then you need to sample it using the sampling frequency. So sampling frequency is how frequently you take those time samples at which you can get those amplitudes. So the sampling frequency has a minimum threshold under which you won't be able to retain all the details in that sound signal. When you have a closer look at the sinusoidal signal of 20 kHz frequency, then there is a crest and there is a trough. So it would be sufficient for you if you capture only the time instant at which there is a crest and there is a trough. So this is the reason why the sampling frequency has to be double of the frequency component of this audio signal. This is what is the Nyquist theorem proposes. Nyquist theorem states that the sampling frequency should be double of the maximum frequency component. So in this way, if the sampling frequency is double of the maximum frequency component, you are at least able to capture the highest point and the lowest point, that is the crest and trough, in that audio signal. In this way, the Nyquist theorem has set a minimum frequency criteria under which the sampling frequency can't go. Just so that everyone doesn't come up with their own frequency standards above this minimum frequency, there are few industry standards set up. So you might already have seen few common sampling rates like 44.1 kHz and 48 kHz. There are actually a wide range of sampling frequencies available out there. The various sampling frequencies that you can find is 8 kHz, 32 kHz, 44.1 kHz, 48 kHz, 88.2 kHz, 96 kHz and 192 kHz. The maximum frequency to which a human ear can hear is only 20 kHz. So a 40 kHz sampling rate would be sufficient to convert these sound signals into digital audio. But then just so that we have a small margin, a guard band of 4.1 kHz is additionally added, and the common accepted industry standard is 44.1 kHz. So for a even more better margin, so we have the 48 kHz. If you see the sampling rates above 48 kHz, that is 96 kHz, 192 kHz and 88.2 kHz, these are multiples of the frequency or sampling rates of 44.1 kHz and 48 kHz. These higher frequency rates are used in studio level equipment, or they are used for the post-production of recording audio and music. So these can be used because it would be very easy for them to downscale after recording in this professional equipment. Now let's look at the second factor that is contributing to the bit rate, that is the bit depth. Once you have time sampled this continuous audio signal, then you get the amplitude at any one particular time instant. Now this amplitude has to be discretized. Let's see how it is done. If you see the audio signal, you have a maximum amplitude and a minimum amplitude. This range of amplitude is broken down into smaller steps, and the amplitude value at that particular time instant is rounded off to the nearest step. Let's understand this with an example. Now consider an 8-story building and a tennis ball. If you drop this tennis ball anywhere in the first floor, that is the roof of the first floor and the floor of the first floor, it would come and fall on the floor of the first floor. Similarly, this would happen if you drop it anywhere in any of the floors. Now build 8 shelves in each floor. Now suppose you drop the same tennis ball in between the third rack and the fourth rack of the second floor, it would come and fall on the third rack of the second floor. So in this way, you are even more precise where this ball is in all these 8 floors. So let's get back to what's bitrate. Bitrate is just the number of bits that each level is used to be encoded into digital format. Now let's get back to our building example. If you want to see onto which floor has this ball fallen down, then you have to encode all these 8 floors into 3 bits because 2 power 3 is 8. Similarly, if you have the racks, then you need 6 bits to encode because there are 8 floors and there are 8 racks in each of these buildings. So there are 64 possibilities. So 2 power 6 is 64. So you need 6 bit to encode. Just like sampling rate, we have few industry standards even for the bit rate. We can find 8-bit, 16-bit, 20-bit and 24-bit and 32-bit encoding systems. We normally use 16 bits bit depth in PCM systems, and for very high quality audio we also use 24 bits. With 16 bits we have something around 64,000 steps, and with 24 bit we have something around 60 million steps. We can also use 32-bit for a very high precision audio, and it's also a floating point number. We very occasionally use it. I've said that there are only 2 factors, that is the sampling rate and bit depth, that would contribute to the bitrate of this digital audio, but there is also a third factor, that is the number of channels that this digital file has. The number of channels depends on whether this audio file is a mono audio, stereo audio, or is a surround sound which has speaker configurations like 5.1 or 7.1. To have a better understanding of channels, do watch the other video that I've made on channels from the same series. Now let's see the actual bitrate of PCM audio data and let us see how it is calculated. Bitrate is the product of sampling frequency, the bit depth as well as the number of channels. Let's calculate the bitrate of a CD digital audio recording. This would have a sampling frequency of 44,100 and the bit depth would be 16 bits. So the bitrate would be 44,100 multiplied by 16 multiplied by 2 because there are 2 channels and this is a stereo audio system. So the product would be 1,411,200 bits per second. As you can see, the bitrate is only calculated in number of bits but not the number of bytes. So you have to divide this by 8 to get it in the number of bytes. In this way, if you calculate the disk space that an 80-minute digital audio would occupy in a compact drive, it would be something around 847 megabits. This is only the bit stream that would occupy the data, but there is also some metadata or a header file which would contain the name of all these audio tracks, which would contain the contributing artist, and also this would also contain the name of the album. Just like both the contributing factors, that is the sampling rate and the bit depth have few standards, even the digital bit rates also have few standards. The available bit rates are 32 kilobits per second, 96 kilobits per second, 128 kilobits per second, 160 kilobits per second, 256 kilobits per second, 196 kilobits per second and 320 kilobits per second. You must have seen 256 kilobits and 320 kilobits the most. Now you must be asking a question. Just in the previous calculation we have seen that the audio bitrate is as high as 1.4 kilobits per second, but the highest bitrate, that is 320 kilobits per second that I've just mentioned, is not even a fourth of it. Here's where the digital audio compression comes into play. All the calculations that we have done was for uncompressed data, but all these standard bit rates are available only for lossy as well as lossless compressions. For you to have a better understanding of this audio compressions, do watch the other video that I've made on audio compressions from the same series. The 32 kilobits per second bitrate is normally acceptable for speeches and was used over the old telephone lines, and 120 kilobits per second and above is normally accepted. So the most commonly used bit rates are 256 kilobits per second and 320 kilobits per second. 320 kilobits per second is the highest quality of audio that you can get through MP3 audio compression or MP3 file formats. This video is part of the series Understanding Audio. I've also made few other good videos like how noise cancellation works, how microphones and speakers work, why few audio jacks are incompatible to few audio sockets, and how audio compression takes place. To have a better understanding of audio, please watch the entire series. Do subscribe to Technocrat if you haven't yet subscribed and turn on notifications to never miss an update from us. I'm glad you wanted to learn something new today and I hope you have learned something new from this video. Always believe in science and make the best possible use of technology. Thanks for watching. Bye bye.